Core OS, which is the stuff that's close to the hardware. Core services, which is an object-oriented layer on top of that kind of makes it so you always are programming an object-oriented layer. Media, because these devices are basically iPods with a phone in them or with a big screen on them, but media is really important to these devices. And then finally, Cocoa Touch, which is the UI layer, okay, all the buttons and all the switches, things like that. So let's talk about what's in each of those layers, kind of, little skimming the surface of what's in those layers. At the Core OS layer, near the hardware, is a Unix kernel. Okay, this is a Unix operating system on this device. Okay, and BSD-based Makr, and so you get everything you get with Unix. You're getting sockets, and you're getting file system permissions, and all that stuff. Plus, you're getting a bunch of other stuff that's kind of specific to a mobile device like this, like power management and keychain access to kind of manage the security of things. Bonjour, which is this kind of network, finding other things on the network. So it's got all that stuff. It's a very powerful underlying operating system. But all of that API, or most of it, is in C, and we want to be programming kind of purely object-oriented layer. So we're going to be mostly operating, when we're talking about touching those things, at the core services layer. So this layer has things like language, things that kind of make the language more powerful, like arrays and dictionaries and strings and things like that. Plus, it has object-oriented ways to access the file system. It has object-oriented ways to find out the GPS location of your device, for example. It has ways to do multi-threading, all this stuff that you want to be able to do, but you want to stay in an object-oriented kind of mindset as you're doing them all. There's a huge layer, foundational layer there at Core Services for doing that. At the media layer, don't sleep on this layer, really important layer. You got video here, you got video editing, you got images, of course, that it can display. It's incredibly powerful audio for doing 3D audio. If you have games, you can make TIE fighters feel like they're ripping by you and stuff. All that stuff is in here. This is the part of iOS that really I can't cover in a lot of depth. I'm just going to try and let you know that it's there, and you're going to dive down depending on what kind of applications later in your life you want to build. But there's an enormous amount there. This is fundamentally a multimedia device, obviously. And then Cocoa Touch is where we're going to spend most of our time. This is where you are going to be building buttons and sliders and text fields talking to each other, and animation happening, things sliding in and out, and fading out and fading in. If you want to get a picture from the camera from the user, you can do that. Things like localization, so that your app can run in many countries in the world and up your sales by doing that. A whole map kit for doing all the 3D maps that you've probably seen in iOS 7, and all that stuff is all in there. And there's even a view in there that's an entire web browser. These apps, okay? And I've divided those into kind of 4 sections here. One is the tools, the actual programming tools. And what's great on this platform is it's pretty much a one tool fits all, okay? There's this one tool, Xcode 5, and everything's in there. Your debugger's in there, all your source code editing, your source code control, the UI building, everything is in this one app. There's a little adjunct there, instruments, which is for things like profiling your app and things like that, memory usage, those kind of things. But you're really always inside Xcode 5, which is really nice because, when you're debugging, you're usually editing your code at the same time, back and forth, back and forth. You're going to different apps and all that would be a pain in the neck. And they've really done a good job of arranging the screen space so that you have a header file, card.h, and you have an implementation file, card.m. Okay, this would be just like in C++, you might have .h and .c or whatever. This is .m. M, I guess, is for implementation. I don't know, but it's M. And so you have these separate things. The difference here is card.h is the public API. That's what your .h file is. It's your public API. Card.m is your private API and all your implementation. Okay? Don't get confused about .h and .m. All .h is your public API. That's all it is. It's what methods in your class you want to make public so that other people can call them. Okay? So let's see what the syntax looks like. In your public API, you must say who your superclass is. Okay? You are not allowed to make your superclass be a secret. Okay, it has to be public, so we have to put it in the header file. And you can see the syntax we use is @interface, the name of our class, which should always match the name of the file, by the way. Card.h should always have the interface for the class card. And then a colon, and then your superclass. Now, the superclass of the card class is NSObject. NSObject is in the Foundation framework, and it's pretty much the root class of every single class in all of iOS, including all the classes you write. Okay? It's this. The implementation side, it looks very similar, but instead of saying @interface, you say @implementation and the name of the class. And here you don't specify your superclass. Okay? Because you're only allowed to specify that once, and it's public, so it goes in your header file. Notice at the bottom of both of these, a little @end. Do you see that? Okay, that just means that's the end of the interface or of the implementation. Okay, so all of your public API goes inside this @interface block, @interface end, and all of your implementation, your private implementation, goes in the @implementation part. Now, if you import, if you have specify your superclass here, you have to import it, okay, which is like #include. It's a little more powerful than #include. In fact, it's a lot more powerful, as I'll talk about in a second here. But you must import it, otherwise the Objective-C compiler won't know what that superclass is. So you have to obviously import your superclass. However, we don't usually, when our superclass is something that's in iOS, we don't usually import just that class's header file, which in this case is Foundation. We actually import the entire framework. Okay? File, we have to import our header file, obviously. Okay? Because our implementation file needs to know what we're committing to publicly in terms of our API. So we have to import that. Makes perfect sense. We can also going to be a string, and so we say property NSString star. Now, is Objective-C will manage all that storage for you. It will allocate it for you and free it for you. Okay? Now, how does it know when to free it? And the answer is this strong thing. You see the word strong there? Properties can either be strong, like this one, or weak. Two things, strong or weak. Okay? And all pointer properties have to be strong or weak because the Objective-C has to know what to do with the memory in the heap. Strong means keep the memory for the thing this points to in the heap as long as I or anyone else has a strong pointer to it. Okay? So this is called reference counting. It's not garbage collection, it's reference counting. So the Objective-C is going to keep track of every single strong pointer to an object in the heap. And as long as at least one strong pointer exists, it's going to keep that thing in the heap. As soon as there are no strong pointers left, it will free the memory out of the heap instantly. Not garbage collect it later, but actually instantly reclaim that memory. Okay? So this is probably new to you. You're probably used to like garbage collection in Java, for example, or explicit memory management in other languages. This is called automatic reference counting, and it's awesome. It's really very predictable. It's much better than garbage collection because the garbage collector can come along later and wreak havoc on the performance of your application as it goes and collects things from the heap. This is very predictable. You know exactly when things are going to be released. It's when there's no strong pointers left to it. What would it mean if this was weak? Okay, if you have a weak pointer, that tells Objective-C, okay, I have a pointer to this thing in the heap, and keep it in memory as long as someone else has a strong pointer to it. But as soon as no one else has a strong pointer to that thing, it gets freed from memory, and this pointer, if it was weak, gets set to nil. Nil means this pointer doesn't point to anything. Okay? Nil is the same as 0. Okay? In other languages, you're probably afraid of nil pointers. Okay? Because you dereference a nil pointer, crashes your program. Right? In Objective-C, you can send messages to nil pointers even, and it will not crash your program. In fact, if you send a message to a nil pointer, it will not execute any code, obviously, because there's no instance there, and it will return 0 from whatever. If that message had a return value, it'll return 0. So you have to be a little careful of messages that return structs, okay? But as long as it returns a primitive type or a pointer, it'll just return 0. So this is going to take getting used to. The fact that we are going to program knowing that we can send messages to nil, to pointers that are nil, and that's good. we'll actually make our code work nicely, and we'll use that to our advantage. And that is definitely going to be a change for you who are used to, if pointer's not nil, then send message all the time, right? Protecting against crashes. You don't do that in Objective-C. You just don't code that way. Okay? So this pointer could have the value nil, N-I-L, which means it doesn't point to anything. Right? So if you have a strong pointer and it points to something and then you set it to nil, now that strong pointer doesn't point to that thing. As long as no one else points to it, you can clean up that memory. Objective-C will clean the memory up for you. Or if you have a pointer, it points to something in the heap, and you make a point to something else in the heap, then you no longer have a strong pointer to that other thing in the heap, and as long as no one else does, it'll get cleaned up. Okay? And remember, weak not only cleans it up, but it sets your pointer to nil, because you only wanted a weak pointer. You only wanted to point to that thing as long as someone else does. Okay? So that's the strong versus weak. The other thing we're going to put in this little parentheses is non-atomic. Okay? Non-atomic means calling this setter and getter that go along with this property is not thread safe. Okay? So you can't have two threads trying to set this property at the same time. Why do we say non-atomic here? Why do we want this to not be thread safe? Because the way we do multi-threading in iOS is not by having a single object that multiple threads are setting on. We usually have a separate set of objects that are running in another thread, like your model, and then other than your UI stuff is running in the UI thread, and they're talking thread to thread. Okay? So we don't need this. And not only that, what's going to happen here when we do this @sign property is Objective-C is going to create that getter and setter methods that I told you about to set this contents automatically for us, and we want them to be simple. Okay? And this is what they're going to look like. We want them to be simple. If we don't say non-atomic, there's going to be all kinds of locking code in there, right? If you have multiple threads and you're allowing multiple threads to access the setter and getter here, then you need locking code. And we don't want locking code, especially if we're going to implement the setter and getter ourselves, which we're going to sometimes. Okay? But the default here is that we don't implement this setter and getter. It's automatically in there for us. So you can see there's three parts to this. There's the @sign synthesize. You see that? That's basically just saying underbar contents is the name of the instance variable in which the property contents is going to be stored. Now we could say @sign synthesize contents equals foo, and then contents property would be stored in an instance variable called foo. But that would be very confusing. So we always use underbar name of the property. Okay? And so that's part one, just basically allocating an instance variable to store this contents property. Then there's the getter. That's NSString contents, return contents. So the dash parentheses NSString star contents is a method declaration in Objective-C. The dash means this is a method. Parentheses NSString star means this is a method that returns a pointer to a string. Then contents is the name of the method. Okay, so the name of the method of the getter is the same as the name of the property. Then the implementation is just return that instance variable that we synthesized. Okay? And similarly, the next method is a method in Objective-C for setting it. And again, dash because it's a method. Parentheses void means this method does not return anything. Okay, that's what parentheses void means. Then set contents colon, that's the name of this method. Set contents colon. Parentheses NSString star is the argument to this method. Contents is just the name of the argument, the local name of the variable in the local context. And the implementation is just underbar contents, our instance variable, equals that argument. Okay, there's no Boolean primitive in C, so Objective-C has defined type def all caps bool. It's probably a short or something, or an int or char, or I don't know what, but you can think of it as a primitive type that's a Boolean. Its value can either be yes, which is some non-zero value, or no, which is 0. And these properties don't need the strong or weak. Do you understand why that is? Because they're primitive types. They're not stored in the heap. Okay? They're just like an int or a float. So there's no memory to manage, so you don't need to know about strong and weak pointers. There's no pointers involved here. This is just a Boolean. So there's no strong or weak. But we still have the non-atomic, because we still want the setter and the getter to be simple, not have any locking code or any of that business. So we're always going to have non-atomic on every property in this class. We will not have a single property in this entire class that's not non-atomic. So just put it in there. I wish it were the default. Okay? But that's what we're going to do. You can see we've synthesized them both. And we've got, because we want our code to read something like, if card is chosen, then do something. If card is matched, then do something. So we really want the getter called is chosen, not just chosen. You know, if card chosen, not as nice as if card is chosen. So it's actually possible to rename the getter by saying getter equals the new name you want. Okay, and that's essentially renamed it. Same thing, we'll do the same thing with this one. Getter equals is matched. Now that getter is called is matched. And I bring this up because you're going to see how iOS does this with Boolean properties. It tends to rename them to is this or has this, depending on what the verb there is. Okay, and again, Objective-C is writing all this code in the implementation, but you don't see it. But it's there. So first, let's assume that they don't match. Okay, so I just made this local variable int score equals 0. You can see that you can assign a variable. Actually, all local variables also start out 0, so I don't even really need that equals 0. But I'm a big believer in putting that in if that's really, you know, what you intend. And in this case, I intend the score to be actually 0, the score of this match, until I go and see if these cards match, right? So it's just a kind of programming style thing here. So how am I going to tell if this card that's being passed in match matches the card that it's being sent to? And the answer is, I'm going to send some messages. Okay? You see the open square brackets notation there? That's the first time you're seeing me send a message in Objective-C. And I'm also sending two other messages in this one line. Card.contents and self.contents. You see both of those? Those are message sends as well. So there's two different syntaxes here for sending a message. One is open square brackets, okay, and we'll talk about that one in a second. And another one is dot notation, card.contents. When do we use them? We only use the dot notation for properties. That's how we call the setter and getter of properties, using dot notation. Okay? Now, here we're calling the getter. Card.contents is calling the getter of the contents property on the card instance. Okay? How do we call the setter? Exactly the same, card.contents, but we put it on the left-hand side of an equals. Card.contents equals, now we're calling the setter for contents. You see? So here we're calling the getter. We're also calling the getter for contents on self, on our self. So in other languages this might be called this, right? But you know what self is, right? Self is this instance that this code is operating on. So we are going to compare these two strings, card.contents and self.contents, to see if they are equal. And we're going to do that with the NSString method is equal to string colon. So is equal to string colon can only be sent to a string. So is equal to string can only be sent to a string. And card.contents is a getter method that returns an NSString. So we're good to go, right? We're sending is equal to string to a string. And the is equal to string takes as an argument an NSString. And again, self.content is a getter method that returns an NSString. Therefore, we have satisfied all the requirements of is equal to string. And we put square brackets around it. And it's going to return a Boolean. Is equal to string is defined to return a Boolean, whether the contents of those two strings are the same. Notice a little bit about who's the sender and who's the receiver here. You can look at this on the slides later. Okay? But I'm going to make this a little more complicated. I'm going to make the argument to match be an array of cards. Okay? So now I'm matching this card that I'm sending this to a whole bunch of other cards. So now I'm going to need some new algorithm to match, right? So again, a playing card match, if let's say you have matching 3 cards, you might give a lot of points if all 3 cards are the same rank. They're all jacks. You get a lot of points. If only 2 of them are jacks and the other one's something else, you don't get very many points at all. If they're all 3 of the same suit, you kind of get a medium amount of points. You see what I mean? So here I'm changing match to take an array as the argument instead of just a single card. And how would I change my implementation to deal with that? Well, I'm just going to put a for loop around my if and iterate through all the cards. And so this implementation, hopefully those of you who are quick thinkers, you can know what this does. This gives you 1 point if the card that's receiving this matches any of the cards in the array. Any, not all, any.
For more, please visit us at stanford.edu.